Alright, so here I am replacing this minus 1 with what that we have already seen here. I am talking about 1 comma 3 third location, that is the one column, and third location, that is 0 1 2 3. So this location element will be changed by minus 1, right? So this is how we are doing. Now, if you wish to check the address first row using a single element, so yes, A of 1. So A of 1 is indicating what? 0 is this row and 1 is this row. So if you are simply writing here A of 1, then you can have the access of the second row, right? So this is how the indexing is being used. Now if I wish to slice my array, we have already seen different kinds of slicing for the strings, for the list, for dictionaries, for sets, for tuples, etc. etc. Now, array also follows the concept of slicing. Why the slicing is being used? Now, let us suppose I am having very huge data of this particular type, right? At a moment of time, I do not require entire data, right? So, let us say this particular information is like I wish to know, suppose this particular table designed for the COVID-19 cases, right? So let's see here. If I wish to check that on the day 3 or 4, how many COVID-19 cases were there in India, right? So I require only this much slice, right? That is the day 3 and 4 day 9. Understood? Now, if I wish to check on the 20th day of March, how many COVID affected people were there in India. So I do not have to go through this entire row time by time by time by time and I have to waste time. I can simply fetch out this slice and can work on this, right? So that at this particular location, index position, how many cases were there? You can have a simple access of it. Now through which you can easily understood the concept. Nowadays you may be listening it daily that in what way of increasing negatives. So by watching a few days of data, you can simply understood that whether at the at the interval of one day, how many cases are being rising in India. Right? So this is again a kind of slicing. Right? Now, if you wish to check that how many weeks this particular data has been there, so you can choose a simple column out of it. Right? So this is how this is the kind of flexibility to access the data is available in NumPy. With the help of this, you can have a single slice of data through which you can have some kind of information. You can directly process on that information. If you wish to make any changes over there, you can always do that. Right? So let's see here how the slicing is being done here. So let's start. A of 0, comma 3 colon 5. So what I really wish from this particular place, that is array of 3 comma 4, right? So 0th row 3 to 5 column. So this is your 0th row and 1 2 3, right? And 0 1 2 3 to 5. And we have always seen that it does never includes 5 but 1 less than 5 here. That is why 3 to 4 column data is there, right? Now again I wish to talk about A of 4 colon, right? Of course this want something 4 colon of data. So what exactly these 4 locations are? Let's check it out. Exactly from where it is talking about 4 comma 4. So this particular information it is talking about 44, 45, 54, 55, right? Now I wish to check and do not care about the first indexing position but second indexing position, right? So I'm not looking forward with the row but some column. So which column it is talking about? 0, 1 and 2, second column. So 2, 12, 22, 32, 42 and 52 type of data is there, right? Now strides are also possible if I wish to check some particular locations data. So how can I check that? second row in column, and after that column, right? So how this information is being getting out of here? 20, 22, 24, 40, 42, and 44. Guys, clear it is? So these kind of strikes are possible. I'm having a question for you. What if I wish to check every information in a reverse order? How can we do? We can simply put single colon, comma, minus one, and you are having the excess of entire matrix into a reversible format, right? So this is orally I'm telling you, but you need to implement whenever you are applying the numpy. Now let's talk about the memory model. Why? Because memory model always works in finding out that how the things are being worked at the background of a model, right? So now if I wish to check that every dimension of an n dimension array is accessed by stepping a fixed number of bytes through the memory. How the bytes are being done? If the memory is contiguous, I already told you the meaning of contiguous, right? Contiguous, sorry, this is not contiguous, this is contiguous. What is the meaning of contiguous? Contiguity means, guys, what we have already seen this thing. Let's see here. I'm not using this entire figure as a whole, but I wish to let you know. If this particular array is of one dimension and it is having four values in it, right? And the type of this particular array is of integer type. So the variable which is being stored at first location will be 0. The variable which is stored at this particular location is at which location? If it is start from 100, then it will be having a memory location of 2 bytes, because integer always stores its variable into 2 bytes, right? So it is not storing some data continuously, but in a contiguous memory location, right? That is the address of, if I'm having 1, 2, 3, 4 variable. So address of 1 is 100, then address of this 2 will be 1002, and address of this 3 will be 1004, and address of this 4 will be 100, further so on, right? So this is how you are defining an array. Now moving ahead from this particular slice and this thing. So our memory, when we talk about in the NumPy, is contiguous. Then all the strides are pre-computed here, right? So we can have very fast or the fastest kind of access for every information. So this is one of the fastest ways, though it looks a little bit tedious that why we require to do it time and again. But believe me, these are the fastest ways to access any chunk of memory location or any particular data from particular matrix or array, right? So I'm calling it matrix because here the arrays are of n dimensions, right? So that is why I'm doing it. Now array slicing with the help of memory model. We have already understood this thing. Memory model allows simple indexing, integers and slices into the array to be view of the same data. Right. So how does this work? Now I wish to know that what will be the result of a of colon comma colon colon 2. How it is showing the information. It is simply showing the information like b of 0 comma 1 location is having 100 in it. So previously whatever information it was having here will be replaced by this 100. Now if you wish to copy something out of it, you can always copy. If you wish to put some value here, that at 1 comma 0 position you wish to put some value, you can always do it this way, right? Now slicing our references. How the slicing our references? A is equals to array 0, 1, 2, 3, 4. Right? Now I wish to access this particular element out of here or any other element out of here, or I wish to change that particular. So B is equals to A of 2 colon 4. So which particular value I am indicating? 2 colon 4. Data in between. How many data variables I am here? 0, 1, 2, 3, 4. Right? So out of 4, which particular I am looking for? 2. So 0, 1, 2. So this particular element I am looking for. Now I wish to change the zeroth indexing position variable since it's a reference variable also. So B of 0 will be replaced by this 0 and the new value of it is having as 10, right? So I can do this thing by 10. Now, if you wish to make this particular 2 as change, then how can you be able to do? Let's check it out, right? Now, fancy indexing, how this can be done, right? So, indexing by position, I can do that is A is equals to A range, right? How can we this thing is being working? So, it is A range, it is not a range, right? A range in which what we are trying to do here that if I want to fill my array or some variable in between 0 to 80 with a difference of 10, right? So this is what the indexing by position. If you wish to do it something by fancy indexing, then you can always having this particular kind of thing that y is equals to that a list of arrays there with me 1 comma 2 comma minus 3. If you wish to print y, then you can take the values that which particular thing it is being indexed, right? So it is talking about here 10, this 20, and from the back 1, 2, and 3. So that is why your print y is having these three values, right? Now using take from this, what you want to take, right? That function is talking about. What I wish to take 1 comma 2 comma minus similar way of data I wish to take from here 10, 20, and from last indexing position 50. This is how the take working is getting here. Now indexing with the booleans. If I wish to fill my array with the boolean values, right or wrong, you can always do that. Then I wish to have what y is equals to a of mask, right? Then mask is having what kind of values? 0, 1, 0, 1, 0, 1. Again, it will take in what kinds of values that one which are positive ones will be reciprocating here. So you will be getting same data 10, 20, and 50, right? So this is what again a fancy kind of index that I am simply putting those value with 111 boolean positions true, and those I wish to have in my arrays using compress. That is again a simple thing, you can always work on that, right? Now fancy indexing to the array is you can also do that. That is my array is having dimension of data 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, then 1, 12, 23, 34, and 40. So this is what the indexing position through which I wish to have my data. Now let's see here if I talk about 0, 1, 2, 3, 4 and 1, 2, 3, 4, then what kind of data it is showing. Then 0, 1, then उसके बाद में कौन सी डिवीजन आ रही है उसको चेक करेंगे, and this is how it is shown the data, right? The orange color is being showing that this is the way through which the indexing will be done. Then let's see here. So how many elements will be selected from here? 1, 12, 23, 34, and 45. Now I am going moving towards which way? I'm moving towards third row. 0, 1, 2, 3, right? And in this 3, I wish to access only elements which are having at at the available rows 0, 2, 5. So zeroth row is having this, second row is having this element, and fifth row is having this number of elements. So guys, this is another way of fancy indexing. Masking, again I'm simply putting what my true or false values. So masking can be done whichever values are at one position, right? So array masking is being done here. Now let us see which elements are there. So masks are being decided here. Mask comma 2 I'm talking about, right? So it is mask is simply telling the way rows here. Comma colon is 0, 1, 2 colon, and moving ahead, which one were true? The first value was true, then 0, 1, 2, 0, 1, 2. This value was true. 3, 4, 5. 3, 4, 5. So 52 will be there. So answer will be 0, 22, and 52. Got it, guys? I'm trying to simplifying things for you time and again. That's why I'm putting it at very simplest way, right? So now, what are the different kinds of data types through which on which this particular indexing can work? So let's see here one more time. There are two related concepts of type: the data type and the Python type. Right? Data type is being represented by D type or the data type. The simple type is helps in extracting the elements that are two Python classes that exist in the hierarchy of classes. Right? So NumPy data types are very different, not different from the simple one. How these things are being worked: Boolean, I'm having the bool type, then elements are 1 bytes inside. Then we are having integer, then these are the range for the integers. Unsigned integers are there, few integer, floats are there, then floats are there. Okay. So float is always a double precision. Floating point values are of 64 bits. Long float represents precision floats. Its size is of platform dependent. Right. Similarly, one of the most important data types in Python programming is complex. Here we can deal with the imaginary values also. Right? So we are also having simple complex, 64 complex, and 128 complex. Right? I don't need to explain here that real and complex elements of complex 64 are each represented by the single precision of 16, 32 bits. Right? So 32 plus 32 is indicating 64 bits. 64 plus 64 is indicating 128. Right? Now strings are of Unicode UTF, right? 32 type. This is a universal code. You cannot make any changes in that. If we are having the concept of classes, then definitely we are having an object data type, right? We present items in an array as Python objects. Records are there. How does this records work? This records works as used for the arbitrary data structure to keep the record. And by default, the data types is of body type. Now, built-in scalar type. See what happens. Scalar is what, and direction is what. Vector is what. Scalar means you cannot make changes further on this data. Vector is when you talk about metrics, matrices. Then there is a scalar multiplication is there, and there is a vector multiplication is there. The dot product and the direction product. So this is what the scalar type of it. Generic it is. It deals with the number. It is flexible in nature. These are having characters, that is string underscore, Unicode underscore, etc. This number is further divided into integers and inexact. Inexact is again they are having to deal with the either the real or imaginary part or the floating part. Right? Single integer and unsigned integer, byte, short, integer character, integer underscore, long, very long. These are the further categories of this. So this is what the generic or the scalar data types, inbuilt scalar types. Data type objects are there. There are 21 built-in static data type objects. New dynamic data type objects are created to handle the alteration of the byte order, change in the element size for string, Unicode, and word built-ins, addition of the fields, etc. 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 Right? So this is what the data type objects. Now to talk about data type field, that which field it belongs to, right? An item can include fields of different data types. So this kind of thing, if we try to do in the normal Python, NumPy, very difficult to do. Now if we wish to check that what kind of value it is having, so we can simply take the data type field. I'm just telling you just for your information. We do not implement it in the normal programming. Now, array calculation methods. If I'm having an array, then how the sum is possible, how the subtraction or addition is possible. Let's see. Min-max, statistics of the arrays, other different methods of array. So let's see it one by one. These are the standard types. We do not have to add to arrays by using, 2 to 4 to 6 number of loops, 6.8 number of loops in a normal programming. Instead of that, we are having ready-made functions in our programming, and you can simply apply them to do that. It's not like that you cannot do, but since we always get such a huge amount of data to work on, that's why we simply use this particular function as an inbuilt function. Now A is equals to array. It is having 1, 2, 3, 4, 5, 6, and it is of float type, right? So I wish to have the sum of this particular arrays, right? So this particular sum is an inbuilt function, and I'm putting simply A here. This A is having what? These much values. So 6 plus 5, 11, 11 plus 4, 15, 15 plus 3, 18, 18 plus 2, 20, 20 plus 1, 21. And since I have converted this entire particular array into float type, it should follow by some decimal. So whenever I am seeing this result, I am having 21 point, right? 0, it is there. You have to imagine. Now, suppose supply the keyword access, right? So how this access is being working here? So sum along the zeroth axis. So access is a very important thing here, that in array, this kind of array, let's see here an example. This is an array. So you want to add along which axis? This is the zeroth axis, this is the one axis, and so on. So according to which axis you want to shift that axis and want to do some kind of addition, that is all possible here in this kind of thing. So what I really want to do, I wish to add this array with which axis is equals to 0. So A is having this array, and we add it with x 0 by 5 point, 7 point, and 9 point. You check the answer and also let me know that how your answer is being generated here. Now x is equals to -1. Yes, we can always add that. We are trying to do it from the reverse side. So from the reverse element, we wish to add 6 point and 15 point. Then what kind of answer we get, you all let me know, right? Because these are very easy things. If you are going through this all, then you can easily work on this all. Now, okay, so hmm, right. Now sum array method, a dot sum. If you are having this sum way or having another this sum way also, then if we talk about axis, then you can also design the axis in this way also. If you wish to have the multiplication of array, then a dot product is equals to this way. You can always follow. So this is how we are doing. Now, if you wish to find out minimum or maximum in an array, then how can you do that? Then what is this array seeing here? This array is having some values 2, 3, 0, 1, right? I want to find out minimum of this array with at the zero axis, right? So since it is a single dimension array, there is no confusion in that. So you'll always get minimum value as 0, right? There is no confusion in that. Then if you do not wish to apply this one and access, then you can have a minimum function instead of anything else, right? So to speed up the operations, so if you are having multiple dimension arrays, in that case you can simply apply them. A minimum a comma axis is equals to 0, so you can get the 0. Then argument minimum, right? Which one is the minimum argument in this, right? For that also we can check a dot argument minimum is which one? It is 2. It is the second variable, right? So at the axis 0, you are having the simplest 0 axis. Now if you wish to check the maximum element out of it, you are having 0, 1, 2, 3. That is the 3 point is the maximum. Again, a min is there, a maximum is there around the axis. Argument maxis, if we check about, then we are having axis is equals to 0. This kind of variable will work. You can always have the statistics methods, because basically we are preparing with the help of Python, we are preparing a base for the machine learning, right? So when we are having array, so what is the mean of that array? How can we access it? How can we calculate the average? How can we calculate the deviation? And what we can calculate the variance? So these are one of the few very important functions in that. So let's see it one by one. Mean is what? Addition of this all divided by the total number of variables, right? So if we are having mean and I wish to calculate this into float type. So 1 plus 4 mean I'm checking it here. So 1 plus 4 is 5 divided by 2 is 2.5, right? 2 plus 5 is 7, so mean is 3.5. 3 plus 6 is 9, divided by 2 is 4.5. I don't think any confusion is there. Then let's say average we talk about. Average and mean here are same. If the number of element increases, then this remains a little bit changed. Now, if I wish to check in the basis of weights, then how the weights I can get out of here. The weight is 1 comma 2, right? Then accordingly, if I check, then I get the answer here 3 point, 4 point, and 5 point. Let me know what does this weight mean here. It's a very simple thing. Doesn't just spot the confusion it has been mentioned here. If I wish to have some standard deviation, then standard deviation says from the deviation how many values have been moving, how the values have been moving, and how far the values are from that particular mean point. So every value is that of the difference 1.5, 1.5, and 1.5. Right? Similarly, you can check the variance also. This is also a mean. Now, here are the few another array methods that you can check. Like if you wish to check some limited value, wish to check the values as different one, you want to change some values, so you can use the flip function. You wish to round off everything, you can use round off methods. So guys, this is basically the numpy is, and this is what a different kind of data type. You wish to check the numerical data type, you can use this d type. If you wish to check the shape of array, this is the shape. If you wish to check the size of array, this is item size, number of bytes, number of dimension, at which particular level array is flat, how can we have the flattened one dimension copy of um, multi-dimension array. Raveling is the returns the viewpoint. Resize tells you how the array is being resized from two dimension, it has been converted to one dimension. Then how can you check? Transpose, yes. If I'm having a matrix, then I must have a transpose of it. Shorthand, this T stands for the shorthand of the transpose. Squeeze, how many way you want to length to resize it. Fill and copy. See, if you want to fill whatever value you want to fill 1, fill 2, fill 3, fill 5, it will fill. To list, to string, a string type, or binary type swap, byte swap. So these are the direct conversion. If I'm having an array, I wish to convert it to a list. This is the feature through which I can do. If I wish to simply convert it into two string, then this is there. For the string purpose, an entire new library is there through which you can work on it, right? Complex numbers, real, imaginary, conjugation is there. So for this, we use complex numbers. Dump. Dump is the way if I have prepared my model and I wish to store that model for the future purposes. This dump is basically used in machine learning. So we are having the pickle methods, pickle libraries in which we use these dump methods. And so simply let you know about these dump files because these are the part of numpy. I'm not explaining it into the deep. I simply let you know that if I am already having a working model here, with the help of pickle library, I just wish to store that model which I have prepared as it is, and later on I wish to use it for some purpose, then I can use it. For search and sort, what kind of searching techniques and sorting techniques I wish to apply, we can always do that. Element math operations are there, that product is there, some cumulative sum is there, round off method, limited way of range, and these are again some different kinds of available functions, right? So if you wish to do simple math array, you can always do that. That is simply by doing a plus b, right? It is not concatenating here like the normal strings or something, but it is doing simple. 1 plus 2, 3, 2 plus 3, 5, 4 plus 3, 7, and 4 plus 5, 9. So this is how it is being done here, right? You can simply do some kind of multiplications, kind of things here, and these are the basic math functions here, right? So this is how for the scalar quantities, if you wish to do some kind of operations, you can do. I am not talking about the vector quantities, but for the scalar quantities, if you talk about the matrix, you can always do such kind of addition, subtraction, remainder kind of things, right? Multiplication kind of things. Of course, if you are having two arrays, you can simply apply the comparison between them also. Equal, greater than equal to, logical and or not, less than, logical or, greater or, and etc. 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 Right? Let's say here by an example. I'm having two dimension array. 1, 2, 3, 4, 2, 3, 4, 5. 1, 2, 5, 4, 1, 3, 5, 4. Right? So let's compare these two arrays. It is simply checking element by element. If 1 is equivalent to 1, yes. 2 is equivalent to 2. 3 is equivalent to 5, no. 4 is equivalent to 4. Yes. 2 is equivalent to 1, false. 3 is equivalent to 3, true. This is true, this is true. So this is how it works, right? Now, if you don't want to do this comparison operator, then you are having an equal, a equals equal of function followed by the matrix, right? So this is how it is being done. Vectorized operations are also possible. Left shift, right shift, you want to do, you can check it out by your own. Trigonometric functions are also available in this, that if you wish to take out the sine, cos, tan, right? And the reverse of those sine, cos, x, logarithm, exponential. So these are all trigonometric functions which are available. Right. So this broadcasting, that how you are broadcasting an array of which dimension, then these kinds of operations are possible. Right. It's a simple thing. I'm not going to believe just for your sake of convenience. I just informing you that these kinds of operations are possible. You want to fill arrays of any mismatched dimensions to any other mismatched dimensions, then you can stretch it, fill the values in that, and get it work out. Right? Just for your reference, because it is part of NumPy, I am comparing it completely here. I am not going into deep that much deep because it is beyond your syllabus as of now, right? So, guys, this is all for today's lecture. The NumPy, that is the multi-dimension of the dimension of arrays in Python. I'm completing it here, and later on we see for some other examples using Python programming. So let's call it a day. Thank you so much.